In this screencast, I want to focus on dummy variables and how you can use them in regression. What is a dummy variable? A dummy variable is a variable that can take on only two values, 1 or 0. Each case being analyzed either has the characteristic being measured, a code of 1, or does not have that characteristic, a code of 0. For example, a dummy variable for gender might code females 1 and males 0. Everybody who has a characteristic of being female is coded 1, and everybody who has the characteristic of being male is coded 0. To appreciate why this 0-1 coding is the essential feature of dummies, consider the following regression model. This model, which we're going to estimate using data from the 2012 NES, is designed to test the hypothesis that women gave Democratic presidential candidate Barack Obama higher feeling thermometer ratings than did men. Gender is measured by a dummy variable called female, which is coded 0 for males and 1 for females. Since males are coded 0 on the dummy, the constant or intercept A of the regression will tell us the average rating among men. Why is this? Because if you substitute 0, the coding for males, for a female, the variable, you get A plus B times 0 equals A. In the language of dummy regression, males in this example are what are called the omitted or excluded category, sometimes called the base category, the category whose mean value on the dependent is captured by the intercept A. The regression coefficient will tell us how much to adjust the intercept for women, that is, when the dummy switches from 0 to 1. Thus, just like in any regression, B will estimate the average change in the dependent variable for a unit change in the independent, and since in this case a unit change in the independent is the difference between a code of 0, males, and 1, females, the regression coefficient will reflect the mean difference in Obama thermometer ratings between males and females. I have used the NES 2012 variable gender, seen here, to create this new dummy variable labeled female, seen here as well. Note that on the original variable, gender, males are coded 1 and females coded 2. There are, as you can see, 2,836 males, 3,080 females. On the dummy, the 3,080 females are coded 1 and the 2,836 males are coded 0. Now I use the old reliable transform into different variables covered in Chapter 3 to create the female dummy. Let's review very quickly. I've already got the code set up in here. I used gender to create female. I named the dummy female. I labeled it female dummy. Here's what the recoding protocol looks like. Old code 1 is 0. Those are males are now going to be coded 0 on the dummy. Old code 2 is going to be 1. Old code on gender 2, that's females, are now going to be coded 1 on the dummy. And just to make sure everything's all tidy and neat, missing to missing, continue. Okay, that created the dummy. Now let's run the regression. I've already opened the regression window. The dependent variable, which is Obama therm, into the dependent box, and I've got the our new dummy variable highlighted here. I'm going to click that into the independent window and just click OK and see what we have here. All right, here are the regression results. How do we interpret these estimates? Well, as always, the constant estimates the value of the dependent, in this case Obama therm, the mean value of Obama therm, when the independent variable is 0, because males have a value of 0 on female. The mean thermometer rating for Barack Obama among males is 53.441. Well, are females significantly higher, lower, or different? Well, yes, they are higher. The coefficient on the female dummy is 5.777, which says when female switches from 0 to 1, on average, Obama feeling thermometer ratings go up by 5.8 degrees on average. Could random sampling error account for this coefficient of 5.777? Highly unlikely. the T ratio is 6.248 with a sig value of 0.000, we can safely reject the null hypothesis and conclude that in the population from which the sample is drawn, women with a high degree of probability do indeed give Barack Obama higher feeling thermometer ratings than do men. In fact, the adjusted R-square for this regression is a measly 0.007. So even though gender is significantly related to Obama feeling thermometer ratings, the variable by itself does not explain a lot of the variation. Let's expand the model. Let's add a variable that's a slam dunk to explain variation in Obama thermometer ratings, and that would be party identification. Here is PID_3. This is a party identification variable in 3 categories. Democrats are coded 1 on this, independents are coded 2, Republicans are coded 3. We're going to create 2 dummy variables from this PID_3. One called a DemDum will be the Democratic dummy. That is, all Democrats will be coded 1 on DemDum, and both other partisan types will be coded 0. We're also going to create RepDum from category 3 on party ID 3. All Republicans will be coded 1 on RepDum, and both independents and Democrats will be coded 0 on RepDum. Do we have to create a third dummy to pick up independents? No. Here's a general rule of thumb about dummies. If you have a variable that has, say, k categories that you want to represent as dummies, you need k minus 1 dummies to accomplish that task, because in this case, independents will be uniquely identified with a code of 0 on both DemDum and RepDum, and they'll be represented as the omitted category and picked up by the intercept. Here's the recoding window, the opening window for creating DemDum. I click PID_3 over. I'm going to call it DemDum. I'm going to label it Democratic Dummy. Old and new values. Old value 1, which was Democrat on PID3, will be new value 1 on DemDum. 2 through 3, which is independents and Republicans, will be coded 0, and then of course missing to missing. Here's the recoding protocol that created RepDum. Again, it's PID3 to create RepDum, named RepDum, labeled Republican Dummy. Old and new values. In this case, 3, which is Republicans, are going to be coded 1. 1 through 2, which is Democrats and Independents, coded 0, and then of course missing to missing. I've run to check my work frequencies on party ID 3, PID 3, and you can see here the Democratic dummy. There are 2,046 coded 1. There they are, 2,046. That checks. On RepDum, there are 1,599 coded 1, and here 1,599 coded 1s. Okay, here's the linear regression window set up. I returned to the window. Female was still in place, so we're going to leave the female dummy in the regression. There's the new DemDum, Democratic dummy, and the Republican dummy. Let's run the results and interpret the findings here. First, get oriented by using the constant, which is 52.02 as a point of reference. Again, because this value estimates the dependent variable when all the independents are 0, 52.02 is the mean Obama rating for males who are independents. Now, why is this? Because all the dummies are switched to 0. Female is 0, that's the male part of the intercept, and both the Democratic dummy and the Republican dummy are 0, that's the independent part of the intercept. The regression coefficient on female tells us how much to adjust the male part of the intercept, controlling for partisanship. The regression coefficients on the partisanship dummies tell us how much to adjust the independent part of the intercept, controlling for gender. Thus, compared with independents, Democrats average almost 30 degrees higher, and Republicans score more than 27 degrees lower on the Obama thermometer. The partisan coefficients are large and statistically significant with huge T ratios and minuscule p-values. Now, what's interesting here, what about the effect of gender? The coefficient on female, 2.9, tells us that women on average score about 3 degrees higher on the Obama scale, controlling for partisanship. This effect defeats the null hypothesis. You can see the t-ratio is over 4, p-value is 0.000. However, in the earlier regression, using the female dummy alone, we found a gender difference of nearly 6 degrees. That regression, of course, didn't account for the fact that women are more likely than men to be Democrats. Taking party differences into account, the gender difference weakens to about 3 degrees, but it remains statistically significant. Overall, however, the model does really pretty well. The adjusted R-square value of 0.427 tells us that all the independent variables taken together account for about 43% of the variation in the dependent variable.